Arcsine, what Arcsine comes from?
Yeah, so there's this problem with arcsine near 90 degrees. Is unreliable, would be maybe my word. Basically by unreliable, what I mean is you really need to think at least twice about this. Okay. And really this is in the context of solving triangles. Right, so we had this example where we had a triangle that was 5 on one side and 12 on another side and 60 degrees in here. And then we were supposed to figure out the rest of the triangle. So labeling bits and bobs, I'd probably label these, I'm going to call that one C, because it's across from the angle I know. I'm going to call these two A and B for angles, right? Doesn't really matter. Like, you can name these whatever you want. If you want to name the opposite side there spout dough, feel free. Right?
Makes sense.
Like, naming is totally up to you. But in solving, I would say, first things first, I know how to get C out of this. How are you going to get C out of this? Yeah, sweet. Bust out law of cosines. So if you do law of cosines, you'll get C squared is, let's see, 5 squared plus 12 squared minus 2
Multiplied by 60, 5 and 12.
multiplied by 5 times 12 times
Cosine of 60.
cosine of 60 degrees. Okay, so you got to go get cosine of 60 degrees somewhere. So I'd go like this. Triangle. My usual triangle for 60 degrees. Oh wait, if I kind of flipped that over and dropped it down here, those should look pretty similar, right? You guys see that?
Yeah.
So let me look at this thing. So if I look at this triangle here, and I kind of put next to it my triangle with 60 degrees in here and a right angle here. Let's see, this is normally 2, right?
Yeah.
I'd like 2 to be kind of like 12.
And you want 5 to be kind of like 1.
So if this is 12,
That's 5 like 1.
6.
so hang on. I went from 2 to 12, right?
6.
So I multiplied that triangle over there by 6 to get this one over here.
Yeah.
So 6.
So 1 should be 6 here,
Should be 6, yeah.
but it's not 6, it's 5.
Right.
So right up, like just looking at this picture, I know this angle A can't be a right angle. Because if it was a right angle, this wouldn't be 5, it'd be 6. You see that?
Yeah.
Okay, so leave that thought for a second, like just, you notice that. All right, go over here, fiddle this thing, you'll get C is the square root of 109. I think most of you guys cracked that simplification pretty well.
10.4.
Yeah, so this is, and this is one thing I wanted to mention. If you're going to approximate, I don't care, feel free, approximate all you like, but let me know. Okay? That is important, especially if you're going to be some kind of engineer or scientist or something. It's really important to know where you rounded, and it's really important to let people know that you rounded. See that?
Yeah.
Okay. Next thing. What did you try, Glenn?
I did the law of sines.
Yeah, you tried the law of sines, because, like, yeah, that's an easy tool, right? So bust that thing up. Which angle do you want to aim for?
I did A.
Okay. So if we do law of sines to angle A, I get sine of A over 12 is, actually, I'll just use the hard values. So actually equals, right?
Sine of 60
Sine of 60
over 5.
over,
I mean, I'm sorry, square root.
over the square root of 109.
Sorry, yeah.
All right. Okay. Then what?
Cross multiply.
Yeah, multiply a little bit. So multiply that thing by 12. Get you sine of A is 12 times, what's the sine of 60?
Square root of 3 over 2.
Square root of 3 over 2. So 12 times the square root of 3 over 2 divided by the square root of 109, which is a really hella messy number. So you get sine of A is about, and then somebody around me here.
I didn't approximate till I did that sign.
Okay. So do some stuff,
So which is 84.5.
and you get like A is about 84.5 degrees, right?
84.5.
Okay, and at this point,
Arcsine is unreliable.
at this point you think to yourself, aha, Arcsine is unreliable around 90 degrees. So you have to think to yourself, okay, look, if I have 5 and 12 here in a 60-degree angle, this could be 84.5 degrees. Or, what other angle has that sine?
Yeah, 95.5 degrees.
Like, remember, right? The arcsine stuff lives over here. So it's only ever going to give you an angle up here in this first quadrant. Okay, so that, it's not capable of giving you an angle on this side, even though those angles could definitely live in a triangle.
Okay.
You see that?
Yeah.
So you're getting this 84.5 degrees over on this side that might work. The sines, which bit? Is it the horizontal bit or the vertical bit?
Sine is the vertical.
Yeah, sine's the vertical one. So there might be another one over here that also works. So where do you get that?
You just do
You
the,
add 5.5 to 9.
or you do the sine of B over 5.
No, don't do that.
Subtract 84.5
Yeah.
from 180.
Subtract
Oh, yeah.
84.5 from 108,
Gotcha.
right? So the thing I want to highlight here is that anytime you take the arcsine of an arcsine to find an angle in a triangle, you should think to yourself, right? A is either the thing you got out of the arcsine, or A might be, well, might approximately be 180 minus that.
95.4.
Which would be 95.5. So then I gotta go wonder, right? Go over here and I go, okay, if I had a side that was 6 here, I'd have a 90. My side's 5, which is shorter, right?
Which means the angle A.
So I'm looking here instead of out there.
So you're going to open that
So that angle got
bigger.
bigger.
That makes sense.
Okay, so it's not 84.5 degrees. It can't be, that's too small. It's gotta be this other one, 95.5 degrees.
Cool.
And the other thing you wanna do, right, is get that third angle anyway.
Yeah.
So trot out law of sines, get that third angle. You'll get that third angle B is approximately, what'd you guys get, like 20?
24.6.
Okay, so you get like 24.5 degrees, give or take. And then you wonder to yourself, okay, does 60 and 24.5 and 84.5 add up to 180?
Nope.
Nope, too small. Okay, so maybe this one's the one that's dorked. So are you gonna fit a 180 degrees minus 24.5 degrees? Are you gonna get that one in that triangle there?
No.
Probably not. You might think about it for a second. I think it's pretty obvious that angle B is gonna be acute, right?
Yeah.
Okay, so I discard this one. I'd say, okay, so this one's my jam. Now they've got to add up to 180. That would be another way you could come up with this 95. But good eye noticing they didn't add up, right? That was good. Cool. Questions on
I should have gotten that.
that? I'm glad you're kicking yourself. That makes me feel good. Like the best thing for me is when students get to the end of the exam and they write me an email an hour after the exam. Dang it! Like I figured it out.
Yep.
Like that lets me know you're going to be good calculus students because you're not going to let it go.
Yeah.
Right?